Okay, dear students, in the last class we have finished continuity 5.1 exercise completely. Now we are going to study differentiability. Okay, differentiability, complete differentiability, 5 point exercise before the 5.2 exercise. All concepts we will study differentiability. Okay, see what is differentiability? Ability of differentiation. That's all. Ability of differentiation. See how continuity we have seen, like that only some conditions are there, differentiability. How continuity was there? Continuity, left hand limit, right hand limit were should be equal to each other. Then if both are equal, then we will compare with main limit. If three are equal, then we can say that the function is continuous. That is called continuity. Like this, here also, let us see some conditions are there. What are those and all. Before that, let us understand some words. Why? Because see, some concepts have come in class 11 NCERT. Now we are in class 12. Okay, in class 12 already continuity we have started. At that time we have started limits also. Limits and continuity we know, but I will write again limit, continuity and differentiability. Why? Because see, differentiability, before going to differentiability itself, derivative we have to write. Derivative has been done in class 11 only. Limits and derivatives, there we have done derivative. And class 12 again continuity we have done. Okay, see, I'm going to write what are all those. Okay, you see, first let me write limit. See, any function, normally all these functions only, for function limit exist or not exist, that we will see. How we are going to know limit exist? What we do normally, left hand limit. See, like this, left hand limit at any point c minus f of x, we will compare with the right hand limit c plus of f of x. If both are equal, then we will compare with the main limit c f of x. Is it okay? First of all, you see, if these three are equal, then we will say that limit exists, or else limit does not exist at x is equal to c. C is very important. Why? Because see, some functions at certain point limit does not exist. Remaining area limit may exist. That is why what we have learned? We have learned this function limit does not exist at x is equal to certain point. That point is c, constant. Maybe x is equal to 2, x is equal to 3, x is equal to 0, or remaining area limit may exist. Like that we have seen in limits. Okay. Afterwards, we came to continue. See, before continuity, even we have seen derivative also. Shall I write derivative? Derivative we have learnt in class 11 itself. Okay, limits and derivative. Okay, let me write derivative. Okay, derivative. Derivative how we have seen. Let me first write formula, then again I will explain to you. Limit delta x tends to 0, f of x plus delta x minus f of x divided by delta x. Okay. See, this is the formula, but let me explain what is derivative. Derivative already we have seen, we have done also. Derivative is the rate of change of function. Like that we can say. The rate of change of function. See, we understand two terms here. Rate, change. Change where change is in function. You see, function is changing. F of x plus delta x minus f of x. F of x plus delta x minus f of x. That means original function is f of x. Changed function. That means increased function. See, one main thing we have to keep in our mind. In class 11, in derivatives, always we have made change in plus side only. derivative x plus delta x plus delta x, like why? Because we have increased slightly, like we have thought. Okay. But what about limit? What about limit? Limit, main limit, plus side minus side, both side we have taken slightly less, slightly greater. Is it correct or not? Definitely correct. Why? Because see, for limit, slightly greater than main limit, slightly less than main limit. At 2, at x is equal to 2 means, see, left hand limit will be 1.9999, right hand limit will be 2.0001. Like that it will be. It will be. But while application of limit, we will apply C only. C minus C plus, in both area we are going to apply C only. Why? Because that is negligible, like we will think and we will apply. But in special cases like modulus of x divided by x, like that is there, then we were taking this as minus C, left hand limit as minus C, 0. If you are seeing at 0, then right hand limit as plus C, like that we were taking, and minus 1 plus 1 and in between is 0, that is why limit does not exist, like we have proved also. Okay. Now you see here also derivative have taken only a plus side only, x plus delta x, that means always positive increment only we have seen. Now you see what is derivative? Derivative is the rate of change of function. See, change of function is there numerator, denominator again that change is there. Rate means with respect to the change, we are seeing the change of function. Change of input, change of function. Function is output, that means change of output with respect to change of input. Directly we can say like that. Delta y by delta x also we can say. This we can say delta y, this we can say delta x. This we are saying delta x only. Okay. See, this is derivative. Okay. See, derivative is there. Derivative we have done. Limit also we have done. Again, we have come to class 12. Class 12, we have started continuity. Write down continuity. What is continuity? Continuity, again we have gone to limits only. You must have understood. Why? Because we have seen left hand limit f of x and right hand limit f of x. Why? Because left hand limit minus right hand limit plus is both equal to main limit. Then we can say that this function is continuous, like. Okay. Continuity. Same limit concept only has come in continuity also. That means if limit exists, then continuity will be there. Like that we have understood. If limit exists, continuity. If limit does not exist, continuity will not be there. Why? Because left hand limit and right hand limit both are not equal. That is why the function is not continuous, like we have written, and we have proceeded like that. Okay. This is the case for continuity. Okay. Now our chapter is continuity and differentiability. Continuity already finished. 5.1 exercise also we have finished. Now we are entering differentiability. Okay, differentiability. Already we said that derivative we have done in class 12, but I will write differentiation first. Because differentiability means able of differentiation. But again you ask me what is differentiation. Okay, that is why let me write first differentiation. Okay, I am writing like this here. Differentiability and continuity both are what we can say, comparison also we will do. Differentiability is the ability of differentiation. Okay, first of all you understand this. Differentiability is the ability of differentiation. That means differentiability means differentiation ability. Differentiation ability. Then again you ask what is differentiation? That also I am writing, you see. differentiation is the process of finding derivative. You understand now? See, differentiability is the ability of differentiation. Differentiation, whether you can do differentiation or not. That is the differentiability. What is differentiation? Differentiation is the process of finding derivative. Derivative already we have seen. We have found derivatives. The process of doing to find derivative, that process is called differentiation. That means with respect to x only we have done until now. In further classes we are going to do with some other this also. Okay, that you keep in our mind. Okay, differentiation. Derivative differentiation is the process of finding derivative. Okay, that you have to understand clearly. This is basic words what I want to tell. Okay, now see, these are all okay, but what about differentiability? Why? Because now we have put heading of differentiability. Okay, now we want to study differentiability, whether any function differentiable or not, that we have to see. Okay, see how continuity we have seen. This function is continuous or not. The process of finding. See, we can say that continuity also able. Ability of continuous. Continuity is the ability of continuation, continuous function. Like that also we can write. Like that, differentiability is also the ability of differentiation. That means whether the function is differentiable or not. Differentiable means differentiability. Not differentiable means not differentiable. Like that we can write. That is called differentiability. Okay. Now how to find this? See how we have find here. Third also, main limit also we have seen. Left hand limit, right hand limit, and we have seen. But now you see here we don't see this one, main limit. But here, now differentiability means derivative we are finding. Na? Left hand derivative, right hand derivative we have to find. You see now. Left hand derivative should equal to right hand derivative. What are these left hand derivative, right hand derivative? Like left hand limit equal to right hand limit, left hand derivative should equal to right hand derivative. What are these? In front of you only are there. See, derivative is this one. Left hand derivative means what I am going to write? I am going to write like this. You see, limit delta x tends to 0 minus, left hand is minus. Write down f of x plus, do you write? No, minus. X minus delta x minus f of x divided by delta x minus delta x. Is it okay? F of x minus delta x minus f of x by minus delta x. Okay, this should be equal to what? Right hand derivative you write. Limit delta x tends to 0 plus f of x plus delta x minus f of x whole divided by plus delta x. This is right hand derivative. Okay, see, why left hand derivative I have taken minus? In derivatives we have not done. Why? Because in derivatives we have assumed or presumed that increment is in positive side. Increment is in positive side. That is why x plus delta x plus delta x we have already taken. Now it is not like that. You see here, increment may be in negative side. That is left hand. One function is there. Both side we have to take derivatives. Like limit how we have taken left hand limit, right hand limit. Left hand limit means slightly less. Right hand limit means slightly higher. 2. 1.999 is left hand limit. 2.0001 is right hand limit. In between 2 is main limit. Okay. Here also you see left hand derivative f of x minus delta x minus f of x divided by minus delta x. Why minus delta x? Minus delta x because here we are seeing that delta x is negative. What about you tell me now? See, 2 is there. For left hand limit, what we were doing? 1.9999 we were taking. Say I have taken up to 4 digits only. Here also 2.0001 I have taken. Up to 4 digits. You see 0, 1, 1, 2, 3, 4. 1, 2, 3, 4. Okay. But what we were doing? While application of limit approximately equal to 2, like we were applying 2 only. In both cases, we were applying 2 only. While applying limit 0 minus also you have to apply 0 only, 0 plus also you have to apply 0 only while application. But what about delta x? See here delta x will be 2 minus 1.9999. Okay? But delta x you have to write in minus. Why? Because finally function is becoming 1.99. See here 1.99 you have to write. 1.99 you are writing means 2 minus 0.001 only you are writing. This delta x how it has come? Because it is minus. That is why 2 has become. See, if delta x is minus, then only 2 is going to become 1.99. Right hand limit delta x is positive. That is why 2 has become 2.0001. That you have to keep in our mind. Okay? That is why left hand limit, right hand limit you have to take. If both are equal, you don't see main limit. Why? Because you cannot see main limit. 0 plus already you have taken. 0 minus 0 plus. If exactly 0 also 0 only. That 0 if you substitute here, what will happen? 0 by 0 will come. That is why for derivative, for checking derivative, you need not see center derivative. No center derivative is there like that you think. Left hand derivative is equal to right hand derivative, it should happen. If it happens, then we can say that this is differentiable. But only this, no. Total 4 conditions are there. I am going to write now, okay? I am going to rub top. I am going to write what are those conditions. Let me write those conditions. Okay. See, one by one I am writing condition. For differentiability, for continuity we have already done, we need not discuss much about continuity. Okay. See, for differentiability, okay, 4 conditions I am writing. First condition, limit should exist. For differentiability of a function. Why? Because see, what we are talking all about functions only. For differentiability of a function, limit should exist. First point. How limit exists we know? Limit exists means left hand limit, right hand limit should equal, and again we are going to compare with the main limit. If 3 are equal, then we can say that limit exists. But we also can say that is continuous function. Function should be continuous. Is it okay or not? That means function should be continuous. See, both are normally equal only. Limit exists and function continuous. Continuity of the function. Both are 99.99% are equal only. Okay? Why? Because for continuity also again, we are seeing limit only. Left hand limit, right hand limit, we are comparing and we are seeing that with main limit, and if 3 are equal, then we are saying that the function is continuous. Okay? And the third one is this one. Left hand derivative should equal to right hand derivative. Okay? left hand derivative should equal to right hand derivative. Limit delta x tends to 0 minus f of x minus delta x minus f of x by minus delta x should equal to limit delta x tends to 0 plus f of x plus delta x minus f of x by plus delta x. These both should equal. Okay. And the last one, you see, which is important, required. Fourth one is a derivative. Derivative should be finite. What is finite? Not infinite. That means something divided by 0 should not come. See, why this is important? See, in some derivatives or limits, left hand derivative also 1 by something by 0 will come, 0 by 0 or something by 0. See, finite means it should not be something by 0 or 0 by 0, both. Something by 0 or 0 by 0. Left hand derivative also 0 by 0 has come, right hand derivative also 0 by 0 comes, means both are not finite. Then that function is not differentiable. First point. Second point, left hand derivative something by 0 has come, right hand derivative also something by 0 has come. Both are not finite. Then that is not differentiable. Any one finite, one infinite has come, that means not finite. Then also left hand derivative is not equal to right hand derivative, that is why this is not differentiable. That means finite, it should be finite and equal. Equal already we have written, third part. Fourth part we have written finite. Finite means any one value should come, whether it may be 0 or less than 0 or greater than 0. Any some real number should come. Okay, any some real number. Minus infinity to plus infinity, but not minus infinity plus infinity. Greater than minus infinity, less than plus infinity. Some real number should come. We cannot say that minus infinity plus infinity are there in real number. That is why if infinity comes means no. Minus infinity plus infinity are not on real numbers. Like that we have studied. Okay, those are not on real number. That is why infinity we should not take as a real number. Okay, those are undefined. That means infinite, undefined cases we should not take for differentiability. That means the function limit should exist, the function should be continuous, left hand derivative is equal to right hand derivative. Finally, function should be finite. That means derivative should be finite. Both derivatives should be finite. Then only we can say that the derivative is existing. Okay? Like that, differentiability. Differentiable, the function is differentiable. Like that, we will say. Okay? Okay, now we have seen that for differentiability, these are the conditions. Limit should exist, function should be continuous, left hand derivative is equal to right hand derivative should be finite. Okay, now we can say that for derivative, function should be continuous means what are all the derivatives are there are differentiable functions. So all are continuous functions only. Like that we will write. Definitely we will write. I am going to rub and again I am going to write here. Okay. You see what I am writing. You understand the logic here. You understand the logic first. Then we will go for some other concept. Okay. See what I am writing. Continuous function we have written. That means all derivatives are continuous functions. All derivatives are continuous functions. Why? Because if function is continuous, then only we are going for checking left hand derivative, right hand derivative. If function is not continuous, then we don't check. Okay? The function is continuous, then we are going for differentiability. That means see derivatives. These derivatives are continuous functions. Okay? But you see what I am writing now. All continuous functions are not differentiable. This is very important. That means, see, some derivative is there, some differentiable functions are there, those are continuous functions. But continuous functions are there one side. All continuous functions are not differentiable. That you keep in your mind. That means, see, continuity is bigger, differentiable is a subset. For understanding sake, I am writing this. You see what I am writing. Derivative is a subset of continuous function. See, continuous function is bigger than derivative. Derivative is subset. This is subset only, no? This open side superset, this side subset. Derivative is a subset of continuous function. If you reverse it, continuous function is superset of derivative. That means, see, continuous functions are there. In continuous functions, some are derivatives, some are differentiable. Not all are differentiable. Okay. That means, see, for derivative, continuous function should be there. But all continuous functions are not derivatives, are differentiable. Okay, conditions are there. This left hand limit, right hand limit, it should match, then only. That is why after continuous function only I have written left hand derivative and right hand derivative. You see here. That means the function should be continuous. Then you will check left hand derivative and right hand derivative. Okay. Now you may ask, sir, which is that function which is not differentiable but continuous function? Modulus x. We will see modulus x continuity also we will see. Modulus x differentiability also we will see. Differentiability means left hand derivative, right hand derivative we will find. If both are equal, left hand derivative, right hand derivative, that is differentiable. Continuity anyway it will come. You see now, continuity first I will check modulus x. Then I will check left hand derivative and right hand derivative, differentiability also. Then you can understand whether this is a differentiable function or not, like. Okay. Let us proceed further. Okay. Continuity of modulus x. These 4 points you have to keep in your mind. The function should be continuous, the limit should exist, both are same. Limit should exist, function should be continuous, left hand derivative should be equal to right hand derivative, and derivative should come finite. Not infinite or undefined. Okay. Now what we are going to find? We are going to find continuity of modulus x. Write down. Continuity of modulus x. See, what we are going to prove? We are going to prove that modulus x is a continuous function, but modulus x is not differentiable. Then we can confirm that all continuous functions are not differentiable. That means differentiable is a subset of continuous function. Okay. Let me write. See, step by step we will proceed. Continuity of x we will see at 3 areas. At x is equal to 0, at x is equal to less than 0, at x is equal to greater than 0. Okay. Okay. We will see at where 3 cases. At x is equal to 0, at x is greater than 0, at x is less than 0. In 3 cases, we are going to see the continuity of the modulus x. Okay. In these 3 cases, see, normally we know straight functions are continuous. Why? Because, see, now something I will write. If at all any function is there, 2x plus 3, 2x minus 3, at x is, here function is changing at 3, here discontinuity may occur at 3. Why? Because functions are changing. If this condition is not there, then this is a continuous function. By virtue of experience, see, we have done several questions until now. In continuity itself, we have done 34 questions, and class 11 also we have done limit. 2x plus 3 is a continuous function. Why? Because anything you give, it is going to give result. 0, less than 0, greater than 0, any result, it is going to give continuous result. That is why this is a continuous function. Left hand limit, right hand slightly greater than, less than, value is going to come, then we are going to say continuous function. Only 2x plus 3. But if you write these along with 2x plus 3, 2x plus 3 at x is equal to 3, 2x minus 3 at x is equal to x is greater than 3. See here, left hand limit equal to main limit we did not take. Left hand limit you see LHL. Left hand limit is equal to, you see, slightly less than 3, you are going to take this one. 2x plus 3, x tends to 3. Okay. Then what is going to come? 2 into 3 plus 3, that is equal to 9. 6 plus 3. What left hand? Right hand limit means slightly greater than 3. 3 minus 3 plus. Okay. Slightly greater than 3. Slightly greater than 3 means you are going to take this function. 2x minus 3. That is equal to, if you apply the limit, what will happen? 2 into 3 minus 3. 6 minus 3, 3 will come. 9 is not equal to 3. Therefore, this function is not continuous at x is equal to 3. See, this function is not continuous at x is equal to 3. Why? Because here, for namesake, one function, but f of x is here for namesake one function, but two functions are there. If only one function is there, means it is continuous at all points. Because discontinuity at 3, except at 3 remaining areas, this function is continuous. Like this, by seeing this experience, we can say modulus x is continuous. Why? Because whatever the number you give, certain result it is going to give continuously. That is why it is a continuous function. But even though we are going to prove, but why? By seeing itself, we can say that this is a continuous function, this is discontinuous function. Okay, let us proceed. Let us proceed. Okay. See now, at x is equal to 0, we will take last. At x is greater than 0, at x is less than 0, we will see, we will rub and we will go for x is equal to 0. Okay, see how I am showing the continuity of this function. At x is greater than 0. Okay. Greater than 0 means what you are going to take? You are going to take any plus 1 or plus 2 or plus c. Or I can say plus c. Shall I write plus c? See, plus c, if I write left hand limit, right hand limit, what you are going to take? That is why, that is 2. See, this concept is for understanding only. Again, I have to change the scale. Okay, I am going to change with k this side, c with this side, and number this side. You see what I am doing now. Okay, at x is equal to 2 I have taken. Understand, 2 is greater than 0 only. Okay, see how I am seeing continuity. Left hand limit, not left hand limit, main limit only you see first. At x tends to 2, modulus x is equal to, see directly I have written, because we don't what we can say, waste the time much for this. Limit extends to 2, modulus x is equal to, if you apply limit, what will happen? Modulus 2, that is equal to 2. Okay, this is main limit. Again, I am applying less than left hand limit. I am not written a left hand limit. 2 minus means left hand limit only. Okay, what you are going to apply really, you tell me here. See, this 2 minus 2 plus left hand limit is for choosing functions. While application 2 minus also you are going to apply 2, 2 plus also you are going to apply 2. Why? Because see, the delta x change is very small. For normal functions, it gives negligible change function. But any division functions are there. Delta x by x means then you have to be careful. At the time you should not 0 by 0 you should not give. What you are going to give? You are going to give minus c by minus c, plus c by plus c, right hand limit. Why? Because this whatever it may be, minus 0.0001 change, but divided by minus 0.0001 only will come if modulus x by x will come. Then finally this is going to give minus 1. Why? Because here x is minus, left hand limit. But out opposite side, modulus x by x, how it is going to come? Plus 0.001 divided by plus 0.001, but modulus is there. Then 1 will come. In these cases, division cases, then we were very careful and we will apply minus c by plus c, minus c by minus c modulus, or c by c or a by a, like that we have done, and we have proved that those functions are not continuous. Like, okay, that we keep in our mind. But here that case is not there. No division. Even if you give 1.9999 are also, or even if you give 2 also, both are same. That doesn't matter. Okay. Then what it is going to give? What we are going to apply? We are going to apply 2 minus that is equal to 2 only. Modulus. Okay. While application itself, we are going to apply 2. Modulus to 2 only. Okay. Even if you give 1.9999 also, you have to take it as 2 only finally. Application you are going to give 2 normally. This is our practice. What about our right hand limit? Again 2 only you are going to give. Why? Because in both areas slightly less than 2, slightly greater than 2, but those are positive only. Why? Because we are at greater than 0. In 2, 3 areas, positive numbers only are going to go inside and positive number only it is coming. Now you tell me at x is equal to 2, is it continuous or not? At x is equal to continuous. Okay, now what I am going to do, rather than 2, I am taking k is greater than 0. In general, I have to take, why? Because I cannot take 2. Okay, k. K is a positive number. K is a positive number. By seeing this itself, we can say. Now, same you make it x tends to k, modulus x is equal to modulus k, that is equal to k. Is it okay? Again, you make a limit x tends to k minus left hand limit modulus x, that is equal to k, that is equal to k. Why? Because see, for writing sake only you are writing k minus k plus. For application you are giving k only. Why? Because for normal functions and all, these are approximately equal to k. That is why we are going to give k. Okay, what about right hand limit? Limit x tends to k plus modulus x, that is equal to k, that is equal to k. Modulus k. Okay, while applying the limit, again you are applying k only, slightly greater than k. K may be any positive number. Greater than 0 means positive number. Okay. Now all are equal k, k, k. That is why we can say that in general at x is equal to greater than 0, the function is continuous. Here we can say function is continuous at x is equal to 2. But here I can say function is continuous at x is equal to greater than 0. Function is continuous at x is greater than 0. Is it correct or not? Definitely correct. Why? Because see, these three limits should become equal. Then we can say that, see, normally, practically, if you see slightly less than, slightly greater than, this is equal to, will come. But the slightly is negligible. The slightly is very negligible in normal cases. In special cases only, that slightly greater or less is going to give any impact. But here, this is a normal case. But I have shown now 2x plus 3 minus or plus or minus 3, 2 function. In that case, the slightly is going to change because function is changing. In that case also, while application of limit, you are going to apply 3 minus 3 plus 3 only. But those functions have changed. That is why continuity was not there. But here that problem is not there. Only one function. Single function is normally we can say that this is continuous. Okay, this is the case of x is less than greater than 0. Now I am writing here x is less than 0. You see, same like. Okay, see what I am writing here, this side. When k is greater than 0, continuity we have seen. But now I am writing k is less than 0. Okay, you see now, limit x tends to k, modulus x is equal to modulus, see k is less than 0 means already this we can write this as minus k or minus k I am writing. Minus k is less than 0. K is greater than 0. Why? Because the minus, that is why I have kept it. Okay. K is less than 0, like I can write afterwards while applying again minus k means you may get confused. That is why minus k is less than 0, plus k is greater than 0. Okay, like that you treat. K may be any number. Okay, but not 0. Greater than 0, less than 0. Not 0. 0 case we will see last. We have seen positive. We are going to see negative numbers. Negative number minus k. Minus k. X tends to minus k, this one. Okay. Now you are going to apply limit minus k modulus, that is equal to k only will come. Is it correct or not? 100% correct. Why? Because the modulus function If you give minus also input, then it is going to give positive output. Okay. Okay. Now again, left hand limit. You write limit x tends to minus k minus modulus x is equal to minus k only you are going to do. See, minus k minus means what you are going to do. You see here, say minus k is 2, minus 2. This is minus 1. See, minus 2 is minus k. Minus 2, minus 2.001 is minus k minus. This side minus 2.001, but this side minus 1.9999. This is minus k plus. Okay, minus k plus means minus only 1.999. Minus k minus means minus only 2.000. But both are approximately equal to minus 2 only. That is why while application you are going to apply minus k only. Minus k, even if you apply, modulus will make it plus k. Okay. Now you see for right hand limit, limit x tends to minus k plus modulus x, that is equal to minus k, that is equal to k. Is it okay? You see, here k you have given, k has come. Here minus k you have given, but plus k has come. That you keep in our mind. But whether input or output is equal or not, we don't bother. We bother only about here output. This output, this output, this output, all are equal or not. That you have to keep in our mind. Okay. Here k we have given, k has come. That is why continuity no. Here continuity because all k's are equal. This k we don't bother. This k you are giving, k minus you are giving, k plus you are giving, but after coming result, those results you have to compare. Okay. Left hand limit, right hand limit means here output k. This k is important. Here also these k's are important. Minus k is not important. Minus k is input only you are giving. Minus k minus k plus you are giving. But plus k has come. Okay, come. Whether these k's are equal or not, that you have to see. Here if you give minus 2 plus 2 will come. Minus 2 minus plus 2 will come. Minus 2 plus 2 will come. Plus 2 plus 2 plus 2. All are equal. That is why when minus k is less than 0 or k is less than 0, that means minus number, the function is continuous. Modulus x is continuous. Like that we can confirm. By seeing this we can confirm. Okay. All are equal. Because these should be equal. Not minus k equal to plus k. No. This k, this k, this k. Output should be equal. Here outputs are equal. Outputs are the limits. The limit should be equal. Left hand limit, right hand limit equal. That equal to main limit. That is why at less than 0 also modulus x function is continuous. At greater than 0 also modulus function is continuous. Okay. Okay. Now we go for x is equal to 0. Okay, what I am writing, you see, observe carefully. At x is equal to 0, there is no k. At x is equal to 0 means 0 only. Okay. Now we are giving input at x is equal to 0. You see what I am writing? At x is equal to 0, main limit x tends to 0, modulus x is equal to, you are applying 0 means modulus 0 only, that is equal to 0 is going to come. Is it okay? Okay. Now you come back again, left hand limit, you see, limit x tends to 0 minus modulus x is equal to. Now you tell me, as per our practice, our procedure, what you are going to input? 0 only. 0 minus 0 plus, while application, see, for choosing the function 0 minus means less than 0 function. If any function is there like this, x plus 3 greater than or equal to 0, x minus 3 less than 0. If such two functions are there while changing at 0, then this is going to make change. Or else, see, here also you are applying 0 minus 0 plus 0 0 only inside here. 0 plus 3, 0 minus 3, plus 3 minus 3, plus 3, both are not equal. That is why this function is not continuous like you write. But is this that condition available here? No. Then directly you are applying 0 only. Here also 0 only you have applied. You keep in your mind. 0 minus also 0 you have applied. 0 plus also 0 you have applied. But for choosing function only, these 0 minus 0 plus functions are helpful. Application of limit, you are going to apply same 0. Why? Because this is slightly less than 0. Whatever I am writing 1.999, this is not the case. This may be 1 point up to 100 digits. That much of small change they are going to make. Small change. Okay. That is why what you are going to do, you are going to apply 0 only. 0 will come, left hand limit. Then you can understand now. Even right hand limit also will come same like. Exactly correct what you have thought. Okay. Again you apply limit extends to 0 plus modulus x is equal to modulus 0, that is equal to 0. Now you tell me, don't see input to output 0, 0, 0 is there or not? Yes. Then the function is continuous at x is equal to 0 also. Okay. See, practically if we think 0 minus means 0 minus 0.00000000000 last digit will be 1. Like this it will be, you see, minus 0 point. See how many zeros you want to keep, you keep. Afterwards only 1 will come. But can you write this equal to 0 or not? You tell me. Why? Because see, this is 0, 0 minus 0 plus both are here. But here this may be minus, this may be plus. But nearest to 0. That is why we can write 0 only here. Even this minus also, the modulus is making plus. First of all, small. Okay. This is small amount, plus only it is making. Plus side already plus will come. Now you tell me left hand limit, right hand limit both are equal or not? Equal. But if we compare this with automatically this is also equal or not? Equal only. Why? Because see, this you can consider as 0 only. But see, for practical sake I have written. Theoretically you should not take this. Why? Because you have to apply 0 only. Theoretically. In examination what we are writing, you are writing this only. 0 minus 0, 0 plus 0 only you are applying. You are not going to apply this. For practical sake I am telling, see, this may be much bigger number, digit. Number is bigger but value is smaller. That means what I want to say, 0 point, these zeros, how many zeros I have written here? Maybe 10 zeros. That may be 100 zeros, maybe. That much of small change. Finally, you have to take 0 only. That is why. Okay? Don't bother about these numbers. Don't bother about these numbers. You have to take this 0 only and 0 only you write. Okay? This is a standard practice we are doing. This like this only you have to understand the concept. Okay? Whatever mathematicians or scientists have done, that much of brain work we need not do. This is the procedure. If you write like this, then examiner is going to accept and give marks. That's all you have to take. Okay? But this is not the case for division. Definitely not continuous. Why? Because here also minus 0.0001. How many zeros you take? That much zeros only you are taking again denominator also. Then finally it is going to give 1 or minus 1. If modulus is there, minus 1 it gives. Modulus is not there, 1 it gives. Right hand side, modulus is there, not there also, plus 1 only it gives. Why? Because here special case is there, division is there. That logic makes you not differentiable of this modulus function. Why? Because in differentiation, derivative divided by delta x is there. Then you can understand the concept. Okay. Now you tell me, modulus function is continuous at x is greater than 0. Modulus x is continuous at x is less than 0. Modulus x is continuous at x is equal to 0. Then finally, can we write modulus x function is a continuous function? Definitely. Modulus x is a continuous function. Finally, you write down. Modulus x is a continuous function. Shall I confirm finally? Yes, definitely. Why? Because at x is equal to 0 also it is continuous. At x is less than 0 also continuous. At x is greater than 0 also continuous. Why? Because outputs are same. 3. Left hand limit, right hand limit, and main limit. Okay, that is why these three functions are, at three areas this function is continuous. That is why we can say that this is a continuous function. Okay. Now we will see differentiability of modulus x.